This is part 1 of lesson 5.3. We are going to be graphing quadratic functions using the vertex form with the transformations we learned in the previous lessons. So in the previous lessons we learned about compression, we learned about stretching, we learned about translation horizontally and vertically, and now what we're going to do is we're going to take a look at this form here, which is the vertex form, and we're going to put a whole bunch of them together. We're going to do multiple transformations at once. Now when you're doing multiple transformations at once, there is a recommended order that you should follow, and we're going to type that order out together. So first you want to start off with your vertical, stretching, or compression. And so remember, that's the A value. So the value right over here, that's the A value there. The next approach is to do the reflection on the x-axis. And so that's when you see the negative A value. So if there's a negative in the front here, then you know there's a reflection that happens about the x-axis. After that, we can do our translations. So usually we do the horizontal translation first, which is, remember, the h value. So the h value in the brackets there. Okay? And then afterwards we do the vertical translation, so up or down, and that's the k value. So the k value over here. And of course, if the k value is negative, it means you're moving down. If it's positive, it means you're moving up. The h value, make sure you do the opposite of what the sign is in there to move to the left or to the right, and we'll see some examples of that in just a bit. If you don't remember all these transformations based on the lessons, please go back and review them. They are very important for you to understand, because now again we're combining all of them together all in one, as opposed to doing just one at a time. So let's get started with some examples. Using transformation of the graph y is equal to x squared, graph all of the transformed graphs on the same grid. List all of the transformations in the correct order. Be sure to label each transformation on the graph. So there's a lot there. This is our first graph in our vertex form we're going to be doing. We're going to list all the transformations that we're going to be focusing on. We're going to start off by graphing y is equal to x squared, and then doing the transformations for y is equal to x squared. At this point, you should know how to make tables of values for your graphs. I'm going to do a few with you slowly just to make sure you understand how to do it. But overall, you should be comfortable with doing that right now. If you're not, you should go back and review some of the lessons that we saw earlier to make sure you know how to do that. So let's examine what we have here. We have our A value over here, and the A over here is a value of 2. And so since we have a value of 2, we know for sure that there's going to be a stretching that's happening. So we're going to have a vertical stretching. So because of the A being equal to 2, it's actually negative 2, but we'll see that in a second. The A is equal to 2. This is going to mean that we have some stretching happening. A vertical stretch. Vertical stretch of 2. So we're moving 2 times faster than the regular x squared. We also have this, let's go choose a different color here. We also have this negative in the front here. So a negative is going to mean that another transformation is happening, and that's our reflection. Remember, we want to do reflection first. So reflection on x-axis, or about the x-axis. So that's because for our A, we actually have a negative in front of it. And then we're going to choose a different color here. We also have these values here, which represent translations. So if we look inside here, this is our h. Our h is 4. So what that means is that we have a horizontal translation. I'm just going to write h there. Horizontal translation to the right 4 units. Remember, you give the opposite sign there. That's why we're going to the right as opposed to the left. And then we also have this part here, k. This 8 is our k. And there's a positive number in front of it. We keep the sign there. And this means that we have a vertical translation up 8 units instead of down. Up 8 units. And so what we're going to do is we're going to draw our y is equal to x squared function. And then after we draw our y is equal to x squared function, we're going to do all these transformations to get to the other ones. So we're going to start by drawing y is equal to x squared. You can make a table of values. So you can do x, y is equal to x squared. And we can choose some different values. We can do -3, -2, -1, 0, 1, 2, and 3. And we can plug those numbers into our function to see what the values come out to. So here we get 9, 4, 1, 0, 1, 4, and 9. And we can go and plug those in and just make our y is equal to x squared graph. So I'll go up by units of 1 in all directions here. So let's do, when we have -3, 1, 2, 3, we have 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We might not be able to use this. Oh, actually, we might be able to. So 9 there. Then if our -2, we have 4. So 1, 2, 1, 2, 3, 4, right here. If we're at -1, we have 1. So -1, 1. If we are at 0, we have 0. If we're at 1, we have 1. If we're at 2, we have 4. And if we're at 3, we have 9. And so what you can do now is connect all these dots. You'll do a better job than I do. Oops, missed that completely. Of course, that keeps going up. And we can label this as y is equal to x squared. So that's drawn in for us. Now we can start doing some of the transformations. So let's do the vertical stretch here. Let's do the vertical stretch. So for the vertical stretch, what that really means is you're multiplying every y value by 2. So our graph doesn't look like there's enough room to do the -3y value there, but let's do that anyways. Write down our information. So what we're really doing is this. We're doing y is equal to 2x squared because it's a vertical stretch. And so what that means is we're going to have 18 over here because we're doing 2 times 9, 8 over here because we're doing 2 times 4, 2 over here because we're doing 2 times 1, 0 nonetheless over here, 2 because we're doing 2 times 1, 8 because we're doing 2 times 4, and then 18 because we're doing 2 times 9. And so what I can do is go plot those values. So at 0, we're still at 0. At -3, I don't have room. That would be way up here, but that's okay. At -2, I have room. -2, that would be at 8. So here's 4, 5, 6, 7, 8 right here. Notice that we are becoming narrower. We're seeing that happening. At -1, I'd be at 2. So right here. At 1, I'd be at 2. And then at 2, I'd be at 8 as well. And I can go and connect those dots. And so here I have the graph, and that would extend as well. I have y is equal to 2x squared. And I can continue now. I'm not done the transformations yet, so all I really did was this stretching. Now I can go and do the reflection about the y-axis by basically changing the signs of each of these. So right now what I'm doing is I'm doing y is equal to negative 2x squared. So I'm taking the negative value of each of these. So I would have negative 18, negative 8, negative 2, 0, negative 2, negative 8, negative 18. And so what I can do now is go do that reflection. So 0, 0, still 0, 0. The point that was 1, 2 has become 1, negative 2. Oops, 1, negative 2. The point that was negative 1, 2 has become negative 1, negative 2. So it's reflecting there. The point that was 2, 8 has become 2, and then negative 8. So here's 2, 3, 4, 5, 6, 7, 8. And the point that was negative 2, 8 has become negative 2, negative 8. Like that. And so here I did the y is equal to negative 2x squared. So let's go and plug that in there. Whoops. And now this makes sense. Our parabola is opening from the bottom. Oh, that's pretty bad. Our parabola is opening from the bottom because we have a negative a value there. And so this would be the y is equal to negative 2x squared. And now we can go into our translation. So we're moving our y's up and our x's to the right. So you can do it one at a time. So basically, or you can do them together. So I'm going to do it together. I'm not going to do a table of values here. I want to show you what it looks like, and we'll do a table of values after just to show you what that would have looked like with the table of values. But if we look over here, we'll do it with one x at a time, and we'll do it 1 point at a time. So we're doing 4 units to the right and then 8 units up. So for a 0, 0 value, we're going 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8. That was our horizontal and vertical translation done. For our 1, negative 2, we're going to go 4 to the right, so 1, 2, 3, 4, and then 8 up. 1, 2, 3, 4, 5, 6, 7, 8. For our negative 1, negative 2, we're going to go 4 to the right, 1, 2, 3, 4, and then 8 up. So right over here. And then for our last points over here, again, 4 to the right, 1, 2, 3, 4, and then 8 up. So 1, 2, 3, 4, 5, 6, 7, 8. Same idea here, 1, 2, 3, 4, and then 8 up. And so now we connect these dots here. That could, of course, be extended below. Whoops, below, that way. This is now the graph y is equal to negative 2 x minus 4 squared plus 8. So notice I did the stretching first, then the reflecting, and then I did the translations. I did the translations simultaneously. I did horizontal followed by vertical. In the tables here, I illustrated one transformation at a time, starting with the y is equal to x squared as a parent graph, then doing the stretching over here, then doing the reflecting. I didn't make a table for the translations, but I will do that in the next video just to show you what that would have looked like. It just was a bit easier visually to go and count my translations up and down, but we can easily have done it numerically, so you wouldn't have had to count it more visually that way.